Next, this section here is the modeling mode. A default model is already set up. So what is it? Signal 1. You can either use the one on the far left or right-click here. You can also double-click here. Then a window like this will appear. This works like a kind of function generator. You can generate various types of signals, like these. So by default, it is set to a sine wave. By default, it is set to a 10 Hz sine wave with a sampling rate of 1000 Hz and a duration of 1 second. So if you double-click the display, as we did earlier, you can see that one signal is connected by default, like this. Now, let's try adding something else here. What should we try? Let's add a different signal. Since this one is already set to a sine wave, you can click it to rename it, and you can use English for the name as well. This is the second sine wave. And for the second one, I'll try using a chirp signal. So when you click OK, nothing happens, right? Why is that? The first one is automatically connected here, like this, but the second one hasn't been connected yet.
Right? If you want to plot them together, select both like this and click OK. If you want to plot them separately,
right-click and create a new display first. Then, select this to display only the chirp signal. If you want to plot both together, select both like this, and they'll be plotted together at the same time. And now you can rename this one to chirp here. If you name it like this, you can reuse the same name later when working here. It's automatically named sine graph. It shows a plus sign because it contains both signals. If you plot them separately like this, only the chirp signal will be displayed. So from here, you can view it here or double-click here to switch between them. If you want to go back to the drag and drop mode and view something there, just click drag and drop on the right, and it will take you back to the previous mode. You can switch between the two modes. Alternatively, you can double-click any work model here, and it will automatically switch to modeling mode. How about we create the note A? Do you know what frequency it is? Does anyone know do, re, mi, fa, sol, la, ti, do? The note A is commonly used for tuning, so it's useful to know its frequency. Do you know how many hertz it is? 440 hertz. Let's create a 440 hertz sine wave and see if it sounds like the note A. Shall we add one more here? By default, there are only two, but let's add another one and create the note A using a sine wave. The frequency of the note A is 440 hertz, so we'll set it to 440 hertz here. And let's increase the sampling rate a bit as well. Shall we try it for just 2 or 3 seconds? And when you run it, it appears like this. It looks pretty dense, right? You can select and view a specific area by holding down the Alt key, pressing the mouse wheel, or selecting the area like this. Zoom in to see the sine wave. It looks dense because of the high frequency. Let's listen. That's what the note A sounds like. What frequency is the note B? I don't know that one either. I think I've already created an example for this. If you go to Examples and select Open Model, you should find a file called signals.mmj. If you open signals.mmj here, you'll see, here I've created the notes sol, la, and ti, and this one combines all three notes, sol, la, and ti. As we've just seen, this is one of the advantages of modeling mode. It's similar to reusing things you've already created before, like MATLAB M files. You can think of them as a kind of reusable source code. You can simply load it and run it as is.
Try opening any of the MMJ files here. There are a lot of interesting examples you can experiment with. Now, what is this one? What is a beat? What do you think it might be? What do you think this waveform represents? Beat can mean rhythm or several other things, but here it refers to the phenomenon called beating. Have you heard of it? Beating. You probably learned about this in high school physics. It occurs when two frequencies are very close to each other. The two signals interfere. Here, we've combined a 440 Hz and a 445 Hz signal. You'll learn about this later, but if you look at the FFT, in the FFT, you can see two peaks at 440 Hz and 445 Hz. Although we simply combined these two frequencies, the waveform looks quite different. Let's listen. Here, you can freely create as many different models as you like. If you look here in the middle, this one is for addition. So, in these arithmetic operations, you have options like addition, subtraction, multiplication, square root, sinh, cosh, and more. Next, in the statistics section, you'll find descriptive statistics, sliding window feature extraction, autocorrelation, outlier detection, and various other analysis functions. For filtering, you have moving average, EMA, FIR, and IIR filters. If you look at these filters, you'll also find several different types. You have standard filters like low pass, high pass, and band pass. In the spectra section, you'll find FFT, STFT, and more. Just click and set the options. So, in the next session, we'll take a closer look at these filters here, and that's the part we'll mainly focus on. Finally, in the spectra analysis section, there are many different functions, but I'll only cover two of them. You should be able to explore the rest on your own. Since we don't have much time, I won't be able to explain every feature in detail.